Okay, I hope everybody is ready to get started with your HSAP review. HSAP is super duper important. If you don't pass it, you don't graduate high school. So with that being said, let's go ahead and review and get started. We're going to start by talking about properties, algebraic properties. And the first one is the commutative property, commutative. And what commutative means is that the order changes. So an example might be, if I said x plus y plus z on one side of the equal sign, on the other side I would say z plus y plus x. So x plus y plus z equals z plus y plus x is an example of commutative property because the order changed from one side of the equal sign to the other. Another property is called the associative property. And what the associative property does, think about who you associate with. You associate with your group of friends, right? So let's say over here, 3 and x are friends. They're associating with each other. And y is not too good of friends with them. But then 3 and x get in a fight. And now 3 is left by himself and x and y are now BFFs. Well, the group changed. Over here, 3 and x were friends. Over here, x and y were friends. So since the group changed, that's associative property. And it's actually associative property of multiplication because what are we doing in this example? Multiplying 3 times x times y. Okay, the next property is one that I bet everybody knows. It's distributive property. So what you do with distributive property, I'll go ahead and put an example even though you probably already know this. For distributive, you take the number on the outside and make it go with everything on the inside. So first, I'm going to get 2 times x, which is 2x, and then 2 times 3 is 6. Okay, that is distributive property. Now the next one, transitive property, I'm going to go ahead and tell you a little story. For transitive property, let's think about this. If I win the lottery, then I will quit my job. If I quit my job, then I will shop on it all day. So what transitive does is it cuts out the stuff in the middle and says, well, basically, what starts the situation, what ends the situation. If I win the lottery, then I will shop all day. That's what transitive does. It cuts out the stuff in the middle and say, what did you start with? What did you end with? That's what you have over here. Okay, and then the last property on this is symmetric property. So with symmetric property, I want you to think of it as kind of like the equal sign is a mirror. Things that are symmetric can kind of fold across each other. So with symmetric property, if you start with A on the left and B on the right, they switch places, they fold across the mirror, and you end up with B on the left and A on the right. So basically, symmetric property, they just change sides of the equal sign. All right, well, let's go ahead and try some matching problems that have to do with these properties. Let's just look at choice A. Let's say, well, what's going on here? It looks like they went ahead and multiplied or distributed. 3 times x gives me the 3x. 3 times 5 gives me 15. So A is distributive property. That's going to go with choice number 2. Distributive property. All right, let's look at B. Well, what's going on? On the left-hand side, I have x squared, x, and then 5. But on the right-hand side, the order changed. I have 5, then x squared. So the property that means order change is commutative. And this is actually commutative property of addition because they're adding. So that's commutative property number 3. All right, let's look at C. Well, what's going on? I have the same order, x, 4, 5, and on the other side, same thing, x, 4, 5. So it's not the order property, but look who's hanging out. Over here, x plus 4 are grouped together. They are associating with each other. But on the right-hand side, the groups change. Now 4 and 5 are hanging out. So when your groups change, that's who you associate with that's changing. So that's associative property C. All right, number 4 for symmetric property. Let's just look at part choice D. Choice D, if 2 equals x plus 5 and x plus 5 equals y, then 2, what we started out with, equals y, what we ended up with. Choice D looks like it's getting rid of the stuff in the middle and connecting the first thing and the last thing. So that is transitive property. Choice D is transitive property. So then E must be symmetric, but let's look. First, 4 was on the left, x was on the right, but then they traded places. Now x is on the left and 4 is on the right. So yes, that is symmetric property. Okay, what we're going to do next is I need you to press pause on the video right now and answer this question on your exit slip. You have to fill out your slip of paper before you leave class today. So press pause, do this question, and then move on. Okay, we have more properties. I know you're so excited. Let's look at the first one, additive identity. And identity means if you do some math to a number, you still end up with the same number. So the additive identity means if A represents any number, what can I add to it so that I still end up with A? Well, that's 0. Additive identity, you take any number and you add 0 to it, you'll still get the same number you started with. So multiplicative identity means if I have a number, let's say I have 7x, and I say, what can I multiply it by so that I still end up with 7x? And the answer to that is 1. So this is an example of the multiplicative identity. Whenever you multiply something by 1, you still get the same number you started with. Okay, additive inverse. Now inverse kind of means the opposite. So it's the opposite of identity because we're not trying to get what we started with, we're trying to get to 0. So basically, additive inverse means if I have a number like 3, what should I add to 3 so that I end up with 0? Well, I should add -3. So you take what you start with and add the opposite of it, they cancel each other out, and you end up with 0. So how does that work for multiplicative inverse? Well, you're trying to think, let's say I have the number 2. What can I multiply 2 by so that I end up with 1? That's what the multiplicative inverse does. Well, you have to take the reciprocal of 2, which means if 2 were written as a fraction, you flip it upside down and it becomes 1/2. So a number times 1 over that same number will always give you 1. And look, the 2's cancel, so I'm just left with 1. Okay, let's look at number 5. Okay, multiplicative 0 property. You guys should know this. Anything in the world that you multiply by 0, you're still going to get 0. All right, some equality properties. Basically, these should be pretty straightforward and pretty easy. If A equals B, then if you add something to the left side, you also add it to the right side. And like an example of this might be, if x equals 2 and I add 1 to both sides, then I'm going to get x plus 1 equals 3. So all I did was take something and add the same number. I added a 1 to both sides. Okay, so subtraction property. If you have two things that are equal to each other and you subtract the same thing from both sides, it's still going to be equal. Multiplication property. If I have two things that are equal to each other and multiply both sides by a number or by a letter or by something, it's still going to be equal. And then division property of equality. If I have two things, let's say I have 12 equals, actually let's say I have this. Let's say I have 3x equals 6. Well, what this is telling me is if I divide both sides by anything I want to, and I'm going to pick 3, I'll still be left with things that are equal to each other. So I'll be left with x equals 2. All it's saying is this is a true statement. All right. So next they want us to pick which property they use when simplifying this expression. So here's the original expression, and let's see what they do. 3c plus 0. Now look here, the plus 0 is gone. So what happened? How do I know that 3c plus 0 is the same as 3c? Well, I know that because that is the additive identity. The additive identity says that if you move, or that if you add 0 to something, you're still going to be left with what you started with. All right, and then what did they do next? How did they get from this step to here? Well, they distributed 5 to both of these things, and they got 10 plus 5c. So it looks like they used the distributive property. All right, let's look at the next step. How do we know that 3c plus 10 plus 5c is the same as 3c plus 5c plus 10? It looks like the order changed. So if the order changes, that's an example of commutative property. Okay, and now, how do we know that 3c plus 5c plus 10 is the same thing as 3c plus 5c in parentheses plus 10? Well, that's associative property. At first, nobody was in a group, and then 3c plus 5c were grouped together. And then last, how do we know that 3c plus 5c is equal to 8c? We're just combining like terms there. Okay, here's your next exit slip question. Press pause, do the problem, and when you're finished, keep going. Okay, exit slip number 3. Again, try this. You're going to use these answers in the bank to fill in the missing blanks. Press pause, press play again when you're finished. Okay, so now we're moving into algebraic expressions and equations. And this table, you guys, is extremely, extremely important. What you need to know is that all the words in this column, this addition column, mean to add. So if you see sum, that means add. If you see increase in a verbal expression, you add. If you see more than, you add. But more than has a special trick to it, and I'll show you that shortly. So all of these words mean add. The next column, all of these words mean subtract, difference, decrease, minus, less than. Now listen, less than has a trick just like more than, and I'll tell you what the trick is shortly. Okay, all of these words mean multiply in math. Product, times, multiply, of. If you see, 30% of a number, of means to multiply. All right, and then the last column, division, all of these words mean divide. Ratio means divide, okay? So now that we are familiar with those words, let's try some examples. Increased by 5. Well, remember, increased by, we just learned on that chart, means add. So what are we adding? We're adding m and 5. M plus 5, that's how we can write an algebraic expression. Example 2, we have to remember product means multiply. So for this, we could write x times 7, or you could put x dot 7. You could even write 7x and you would be just fine. Okay, or you don't even have to put parentheses. You can just write 7x like that. All right, now example 3, this has the words less than in it. And remember, I told you less than means subtract, but it has a special trick. So since less than means subtract, I'm going to go ahead and put my subtraction sign. But here is the trick with any less than or more than problem. Whatever they put in front of the less than actually goes behind the subtraction. Then whatever they write the words in the back, we put that in front. So 4 times a number, I'm going to let my number just be x. So I can represent 4 times a number as 4x. But the key is, for less than and more thans, you have to switch the order. Whatever they say first goes in the back. Whatever they say second goes in the front. All right, so example 4, let's try this one. It's a more than problem, and more than works the same way as less than. We're going to use a plus sign because it's more than, but we have to switch the order. So if they said the word 2 in front, it actually goes in the back. If they say 6 times a number in back, I'm going to use X again, it actually goes in front. 6 times a number can be written as 6X. So most of the time, in most things, you go the order that you see. But for more than and less than problems, you have to switch the order. All right? So now quotient, if you remember from our sheet, quotient means divide. Well, what two things am I dividing? A number, I'm going to use X as my number, and 12. 12 is the other thing I'm dividing. And usually where the word and is, that's where the symbol goes. So a number divided by 12. All right, let's keep going. Exit slip number 4. Press pause. Try this question. When you're finished, keep going. Okay, let's go ahead and simplify some expressions. This is a long, complicated, ugly expression. And I'm going to sort of be thinking order of operations when I do this. And I'm noticing parentheses here. First thing I'm going to do is distribute this 2 to everything in parentheses. Now what about this 3x? It's still in the front. I don't have to do anything special with that. I don't distribute it. I just distribute the only thing in front. So 2 times 5 gives me 10. 2 times negative, and this is kind of like a hidden 1 there. 2 times negative 1y is negative 2y. And now I'm going to keep writing the rest of my problem as I see it. Okay, next I'm seeing a lot of like terms we can combine. Some people like to change the order and write the like terms beside each other. I'm too lazy to do that. I'm just going to look. Here's an X piece. Are there any other X pieces that I see? Well, I see this positive 2x here. So 3x plus 2x. You take the sign in front of the piece you're taking. 3x plus 2x, I can combine those and get 5x. So now I'm done with my x pieces. I'm going to scratch them out so I don't get confused. All right, next I see a positive 10. Do I have any other plain old numbers that don't have any other letters with them? Well, positive 10, and that has a y, that has a y. Here's a minus 6. So I'm going to think positive 10 and a negative 6 give me a positive 4. Okay, so now I've combined my numbers. That is excellent. Last, I have a negative 2y and a positive 7y. When I combine those, negative 2y plus 7y, I'm going to get a plus 5y. So guys, when they say simplify an expression, I want you to notice something. There's no equal sign, so we're not solving anything. We're just simplifying, combining like terms, and once we've combined as much as we can, we're done. There's nothing else you can do for this problem. All right, here's what I'd like you to do. Press pause, try number 5 here. When you're finished, press play. Okay, last, solve the following equation. Okay, so now notice there is an equal sign. So I'm going to, for this one, solve and do my very best to get x all the way by itself. And when you do that, we can start by subtracting 9 from both sides. I'm trying to get x by itself. You always get rid of the adding and subtracting first. Let's see, these 9's will cancel. So I have 2x equals, now negative 13 and a negative 9 gives me negative 22. All right, x is almost by itself, but I got to get rid of this number in front. If they're multiplying x by 2, I do the opposite, which is divide x by 2, and I get x equals negative 11. Okay, we're finished. All right, to solve a multi-step equation, this is a long, awful problem, so I already kind of have the steps written out for us. Let's see what happens. First thing we're going to do is distribute. Distribute that 2 to the y plus 4. and I can distribute this 5 to the y minus 3. So basically, you guys, you want to simplify each side as much as you possibly can. So on this step, I have where I distributed 5 plus 2y plus 8. And over here, I distributed and got a 5y minus 15 plus 10. But now I see like terms I can combine. 5 plus 8 gives me this 13. And then I have a negative 15 plus 10 that are giving me this negative 5 right there. So after I combine like terms, here's what I have. Now here's the trick, you guys. You may be noticing this problem. I have a y on both sides of my equation. And that's not good. When you have the variable on both sides of the equation, you've got to move it over so that it's only on one side. And I always like to move the smaller variable. It doesn't matter. But what I did for this example was subtracted 2y from both sides. And when I did that, my 2y's cancel. I still have my 13. But over here, 5y minus 2y gives me 3y. And I still have this minus 5. Okay, to keep going. Now I just have y on the right. When you have y on the right-hand side of the equal sign, here's my equal sign, you have to move the rest of these numbers away. So I'm going to do that by starting by adding 5. You always get rid of what you're adding and subtracting first. And I'm left with 18 equals 3y. And last, you divide by 3. And you get y equals 6. All right, so that was a tough one. Okay, last question, exit slip number 6. Press pause, and when you're done, let me just make sure. Yep, when you're done, this is your last question. You can turn this into your teacher. All right, I hope you have a great day.